Welcome to 180 Maths. Today we're looking at probability, in particular tree diagrams. Tree diagrams are really helpful to use in probability because they can represent the number of elements in the sample space. Okay, let's have a go at a few questions to revisit what the meaning of sample space is. Okay, sample space. What is it? What does it mean? Well, basically it means that we need to list all possible outcomes. So for example, if I was going to roll a die, which is here, I would want to list all possible outcomes. And they must be 1, 2, 3, 4, 5, and 6. If I was to roll a coin, a 50-cent coin, okay, the sample space would have to be heads or tails. It cannot be any other outcome. Now, let's put the outcomes together if I was going to toss a coin and a die together. Okay, I've got the coin in my left hand, I've got the die in my right hand. I'm going to throw them both up in the air and I'm going to see what the probability of obtaining, let's say, a tail and a 3. So a T and a 3. Let's see if I can find the probability of a T3 landing out. Now the best way to do this is using a tree diagram. Okay, the coin toss. I've got my heads here and I've got my tails. Now for rolling the die, my options were the sample space is 2, 3, 4, 5 and 6. And again 1, 2, 3, 4, 5 and 6. And I can just link them up so they look like a tree. Okay, and now I can list the outcomes. So here, my first outcome was H1. My second outcome was H2, H3, all the way down to H6. Now my outcomes for my tails was T1, T2, all the way down to T6. So obtaining a T3, as you can see here, a T3 would be 1 out of 12. Okay, let's have a go at another question. How about if I had 4 pieces of paper and I wrote the number 4, 5, 6, 7 on each piece of paper? Then I chose at random to form a 2-digit number. So I've got 4 pieces of paper on my desk here. And each number has a 4, a 5, a 6 and a 7. And I'm just going to pick up one randomly. What is my options for my first digit? Pause the video and have a go. Okay, my first digit would be 4, a 5, a 6 or a 7. They are my options for my first digit. What would be my second digit option? Well, if I've already picked up the 4, I can't pick up the 4 again, so it must be a 5, 6 or 7. Now if I've picked up a 5, I can't pick up a 5 again, so it must be 4, 6 and 7. A 6, I can't pick up a 6 again, so it must be 4, 5 and 7. And when I've already picked up my 7, the second digit must be a 4, 5 or a 6. So therefore now I'm going to list my outcomes. I've got 45, 46, 47. I've got 54, 56 and all the way down to 76. Okay, so my 45, remember, comes from the 5 and the 4. My 76 down here comes from the 7 and the 6 to form the numbers. So there's my sample space. Okay, last question. Let's say I tossed 3 coins to represent the sample space in a tree diagram. I want you to have a go at this one by yourselves. So my first coin, second coin, and third coin. Okay, have a go at drawing a tree diagram. Now I've done one up already, so I'm going to show you this tree diagram from tossing 3 coins. So there it's coming now. There we go. Okay, as you can see here, my first toss was a heads or tails. My second toss was a heads, tails again. Third toss, heads, tails. So my outcomes, let's look at these outcomes here. I've got 3 H's, H, 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 because that's from heads, heads, heads. Let's look at this one here. I've got tails, heads, heads, tails, heads, heads. Okay, so that is your sample space. Let's have a look at obtaining 3 heads in a row or 3 tails in a row. Let's have a possibility. How many of 3 heads in a row can we get? So we've got 1 here. And let's have a look again. No more heads, is there? How about 3 tails in a row? The 3 tails in a row here. So the probability of obtaining 3 tails in a row would be 1 out of 1, 2, 3, 4, 5, 6, 7, 8. Therefore, it'd be 1 over 8. Stay tuned for more lessons. Hopefully this has helped you, and good luck.